Thank you for coming here. So it's a tough time right now. It's after lunch. So I have short time, only 30 minutes, but I decided to dedicate 2 minutes to some fun video. How many of you been to AnacondaCon in 2018? No one. That's great, because that means that you didn't saw this movie. So check it out.
There's one thing you should know about me. I specialize in machine learning, a very special type of machine.
You're talking about deep learning.
So what's the most powerful thing in the business world? Capital? Intellectual property? No. A deployed deep learning model. It's not accurate enough. We need to go deeper. Models work with test data in the sandbox, but it's only when we try to integrate the real data on the production cluster that we realized something is not right. Think about it. How did we get here?
Well, I started fitting the model.
Did you spend cleaning it? Did you have to pay a vendor to hydrate it? Did you have to blackmail a VP to run a VLOOKUP?
You're right. This must be test data. We're in the sandbox? Why don't all the data scientists try to escape?
Your data is clean. You have a GPU all to yourself, and your model accuracy is perfect. It's easier to just let yourself be deceived. It's called biception.
Why are they shooting at us?
They're the IT team. They won't let our Python models out of the sandbox. They want to rewrite everything in Java. Model's too accurate. The data is real, but is this a real cluster?
All our tools are here. Anaconda's installed. Everything just works. It's too perfect.
We're still in the sandbox. We have to get to the production cluster.
What is that?
That's GDPR, but we don't have to worry about that.
If I do this, I get to go home.
Because we're trapped in a dream world within a dream world?
No, because my son has a soccer game at 6 and I need to get a jump on traffic.
There's no GPUs available.
Hold on. It looks like the IT guys are using them to mine Bitcoin?
No, Dogecoin. Bitcoin mining uses too much energy and contributes to global warming. And Bitcoin has really become a settlement layer and not a currency.
Shut up! Enough with all the stupid coins and cryptocurrency hype.
Biception. All right. You spend two data every time you're doing modeling a model. You do, but most chances you don't. So a little bit about myself. My name is Gershon Celniker. I'm running the data science and AI group at Checkpoint, the central group. We have a big practice of data science in Checkpoint. Total of around 30 data scientists that work on many different projects. A little bit overview about what we're going to talk about, a little bit about Check. Then I'm going to talk about data science and machine learning biases, from top down all the way to the details and the instance level. Then I'm going to talk about something test-driven data science, best practices, hands-on session, and I will show you Octopus in action. Yeah, okay. I will also put it maybe more up. All right, can you hear me now better? Sort of? Okay, I will talk even louder. Okay, so Checkpoint, we have products. You know what? We'll put it just very close up. Can you hear me now? All right. Okay. So in Checkpoint, we're working on network, endpoint, cloud, and mobile. And I will just show you the type of data we're working on. Everything that runs on the computer. So we have executables, we have network, APKs, the install software on mobile. Twitter, we're doing some OSINT, all kind of documents, cloud network as well. That's the data science thing. Very, very, there's lots of variety in the data science in Checkpoint. So I'm going to talk, this is a very important one, GIGO, garbage in, garbage out. This is very important. When you didn't validate the data, and you have not high quality, not free of error, biased data, you will get a very bad model, a garbage model. I can give you some examples. There is an example of Uber. It's a video I'm showing it. Uber just go on red lights because it was trained on Chicago roads and didn't trained on Boston roads. So it's a little bit different type of red light, and it didn't recognize it well. So it was a problem with data. Another anomaly with Uber, if you're talking about Uber is that there was a terror attack in Sydney, and suddenly the prices went up by 4 times more. Because they never experienced this kind of outage of service. Another example is here from Israel. This guy, poor guy, just took a picture of himself and says "Good morning" in Arabic, and it was translated to attack them. And to get to it wasn't good, so he was then Shabak, not so. So here, what happened? We received. This is a row curve, and we received suddenly this green line, which is amazing. We have really, really good model, and we did nothing. It was only new data. So what actually happened? We test data. This is our client actually. Our data that we are trained on as part of our testing. It's like we knew the answers, and the row curve was amazing. I don't understand how come it wasn't perfect. So it was still, even on the data that we already trained on, we weren't perfect. We didn't. It was actually a good sign. But yeah, it's a big fuck up. And we were thinking that we were so good for months. And then we realized something is not right there, and it took us a while to get it right. Another interesting one, motion, a very important model that serves thousands of people. We just passed it from the wrong, they changed, we passed, and this JSON file, they changed the development team, they changed area where our was supposed to be, and what happened, this is actually going to show it to you later, it's called missing info. It's one of the packages on Python, and what happened here, you see there's data, suddenly it's constant. And what happened with this feature, it just disappeared. It's like running a car with only free, it was for a while, and it took us a while to understand that we have an issue with that, and really checking the distribution of features on production as well. We expect that the distribution of features in training will be as close to production, and if we see that there's a big difference between the two, then something is wrong here. So this kind of tests in order to avoid these kind of things. Because during training, everything was fine. In production, suddenly the feature disappeared. It was a very bad one, outdated ground truth. So in cyber security, ground truth, the more time goes down, better our confidence in ground truth. And this is really, really important. So we have confidence after a week, and after a month, we know it was a cyber attack or not a cyber attack. And what happened here, our GT was really, really outdated. Like, who wants to eat this hummus from a tin? I don't think so. And we trained on this data, on this outdated ground. We also evaluate ourselves on this GT. And here, it was really problematic that how we figured out about it. False positives and false negatives, and we suddenly saw that the false positives are actually not false positives because they actually were true positives. How we figured out that the GT that we use for, and repeat the answer. So the answer was you can try to figure out what are the times that it's a false positive one. Try to forecast them maybe. What else? Huh? That to give him more additional information about this one. And yeah, so you know what we did? We decided to remove the feature. It's a bad one. It didn't make so many false positives. And we decided to remove. By the way, it was a concept drift because this feature was amazing, and then it was one of the services that we used, and then there was a bug in the there was a bug in one of the services, and suddenly there's lots of false positives. So the decision was to just remove it, and there was another feature over here that we decided to remove as well. And it's actually, so this model was about email phishing. So if it was benign or malicious email, phishing email, or it's a regular benign email. So actually that feature over here, we didn't know much about it. We just know the name, and we didn't know that the guy that generated this feature and wrote it not in Python but in Java. We saw the perception that we don't like Java, and we didn't even notice what is all about this feature. This feature was a whitening feature. It wasn't incriminating. This is a feature. This is a malicious email. It was actually a whitening email, a whitening feature. And what we decided to do, and thank goodness, we decided to see the feature importance. And if you check the feature importance on LightGBM, CutBoost, and Random Forest, you will get some kind of feature importance, but it doesn't give you the direction. So what I did, I decided to do -1 is for phishing emails, and B9 is 1, and I decided to check the direction. And what we saw, this feature is actually a good feature. It's a whitening feature. It does exactly what it needs to do, and the fact that it in the false positive emails, that's exactly that it was supposed to do. So we almost removed the feature that was very beneficial because we didn't know the data, we didn't understand what this feature was supposed to do, and we decided to do the easy thing, just remove the feature. So it was just before the merge request for deleting this feature. We did this test, and we figured out that it actually does exactly what it needs. So feature importance with in this here I ran a lasso with regression. With the direction is very important, so you can see the direction of the feature. These are many junior data scientists do this fancy mistake all over again. So this is the nice model, all right? This is a model for traffic, encrypted traffic, I think. And what we have here, I'm sorry, I just took it with my phone, so the quality of this screenshot is not that good. So there's features, some of them are binary features, some of them are continuous, and look what happened, the binary features got to naive-based, and there's lots of different random extra trees, gradient boosting, and then there's a nice logistic regression as a meta classifier and an output. Think about the headache to train all these models. It's unbelievable. You need to separate each one, you need to train test, you need to there's 5 models over here to train this solution. What was my suggestion? My suggestion back then was to replace it with XGBoost. What do you think happened? It was a reduce in performance? Huh? That's the guy that said that we need to, that will be no bias. You think that will be reduced in performance, all right? Anything else? Sometimes stacked models make sense. In this case, it really didn't, and actually give you the answer. What happened here, that the XGBoost was much, much better than all of them, all 5 of them. It was very easy and robust to train. It was much, much easier. Only if there is a specific, like maybe different domains of features and stuff like that, that you do some kind of stack models. But in this case, that it's the same data, going to this for it just complicates stuff, and in the end, the performance wasn't so good. So if you have A to B and you want to, and you have a keep it simple way that drives you the same results, in this case, the XGBoost was even better. Take the keep it simple one. Oh, sorry about that. We already saw that. All right. So what are the challenges in data and modeling? Data provenance. What is the origin of data? What is the data versioning? Can I trust the source? And in Checkpoint, we use so many different, we have out of 60 products of Checkpoint, we have AI models on 7 of them. And we depended on many, many different features that we don't control: the quality, and the constant drifts, and many other dependencies, and we have to really validate the data all the time. So I don't trust most of the, I'm starting with 0 trust. I don't trust the data, my input, and I'm checking it and I'm validating it. And today I will show you some ways to validate your data. Data quality, is it data error-free? There is no, well, maybe in Kaggle there are some error-free examples, but in real life there are always some kind of artifacts, and we will see actually on the Kaggle example. Data bias, does it really accurately reflect the population? So what we saw with the gorilla and with red lights and stuff like that, no, it didn't. There was just a weak point of the data, and then it resulted in a weak point of the model. And of course, model biases. Does it really threaten everybody fairly? So what is my proposed solution? More data crunching, more EDA, less fit predict, and people love doing fit predict all the time, and get some info, and play with models, and then do some stack models. Take more time to data crunching, and try to do today I will show you some tools, more test-driven methodology for data science, and stacked and less stacked models. Right, so unit test, everyone knows what is unit test, and it's very important to have a unit test on simulated or example data snippets, very important. Sanity tests are even more important. And I will give you an example of a sanity test. How many of you are familiar with the banana split? Banana split, 1, 2, not so many. So if I'm doing a classifier, NLP classifier, I'm using, for instance, Word2Vec or BERT, and I don't, and my data shouldn't include the banana split or banana term, I can just test it really fast. What is the word embedding I'm getting for banana split? If it's not 0, if it's something weird, that means that there is some bias and I didn't train it correctly. Data integrity tests are very, very important. Between each step, I'm doing data integrity. What is the input that I'm supposed to receive? What are the distributions that I'm supposed to receive? Is there missing information, missing data? Is it really, really, is it according to my requirements? I will show you a really, really nice tool how to do it automatically, and it's really, really fast and simple. And it's nice because I have time. All right. So I'm going to present octopus. So what is octopus? They have lots of hands or what's tentacles? Yeah, thank you. So there's data validation, data integrity, detection of data leakage, detection of artifacts and inconsistencies, very important. Feature examinations, feature importance, anomalies, and also some initial data crunching. All right, hands-on. So what we're going to do, I'm going to release this package called Octopus for open source, so everyone will be able to use it. For now, I'm just going to show you and give you a teaser. So you can email me back, and it will be shortly on Checkpoint GitHub. All right, so what I took a data from a bike sharing. It's a Kaggle. I couldn't show it on the Checkpoint data, so I took it on open source data, a bike sharing domain. So the data is very simple. There's season, holiday, working day, weather, temperature, and in the end, I need to predict how many. It's a regression problem. How many bicycles are going to be rented from a specific point, from a specific station? All right, very simple and straightforward data. And in order to show some of Octopus capabilities, I added artifacts to the data. All right, so some of them are my own artifacts; they're not real. So bear with me. All right, so first thing, pandas is really amazing, and you have pandas describe. Oh, sorry about that. Yeah, so pandas describe is a very important tool. It can give us kind of like a box plot for each one of the features. So we can see where is the median, where is the standard deviation. It's nice. Here, there is something that's called the data frame summary. It's a little bit better than the pandas describe. And why is that? Because it gives us also the unique values. How many of them are unique or not? The missing percentage, and also what are the types. I can see right away that there is some problem. Pandas profiling, how many familiar with pandas profiling? So actually, Octopus, in a way, it's like an enhancement of pandas profiling, and there are many other people that did some enhancement of pandas profiling. Check it on GitHub, really nice stuff. I'm not going to talk too much about pandas profiling. This is something really nice. This is the missing info visualization. It can show you which are the features, which are instances that are missing some of the data. You can see right away something happened, and there is like a lot of white here, that there is a problem with that specific feature. I can show you really quickly. There's some feature that it's totally missing. And now I want to show you something really, really quick, test-driven data analysis. How many of you practiced that, tried it? No one? That's not good. You should try it. It's really, really important. So it's a package called TDDA, yeah, test-driven data analysis. You install it, and I will show you something really, really interesting. I'm taking the data, let's say it's my training data, and I'm building constraints. Probabilities of the data, constraints, what are the maximum, the minimum values, what are the percentage of missing values. I'm building constraints, and it's very easy to do. Constraints, discover constraints, X-train, that's my training data. And then I'm opening my test data. First of all, this is the constraints, this is how it looks like. For every field, it gives me the minimum, the maximum. deviation, stuff like that. And then I can give you an example here. I opened my test data and verified it with the constraints that I built just before. You can see that 45 tests passed, 5 tests didn't. And for each feature, it gives me that, for instance, the temperature, there's 1 failure in maximum nulls. There's too much nulls over there. And another feature, there was 1 failure, also nulls. There was another failure here. Actually, there are many with maximum nulls. And I think even sometimes it's like too many negative numbers or stuff like that. It's really simple to use. It should be, training and test should be the same. And if and for each failure like that, we usually check it out before going to production. And you can actually see it in the data frame really nicely. So that's TDDA. I'm going to show you some capabilities of Octopus, and I don't have so much time, but if you want, I can send you more information, and I will have it in the presentation. So what we can see here, I'm doing visualization. That's the Octopus right now. Okay. So this is the main thing. I'm trying to run Octopus. I'm giving her the test data and the train data. And if you're doing cross-validation, so you need to give the cross-validation split. And then I'm doing the feature shape, testing data leakage. For instance, this one is failed. I'm testing features if they are constant or not constant, or if they're an artifact. And I can explain afterwards how I detect artifacts and cheat features. And also skewed. If some of the features are extremely skewed, I'm also alerting that. And these alerts, you can take it in nice and good data set. The alerts shouldn't be that high. This is an example one that is very problematic. And for instance, here we have even duplicates instances, a lot of them, 11%. And here I show what are the data leakage, which are the instances that are the same between the test and the train. Thank you. Correlations. Lots of different correlations, and here it's a very nice seaborne package that you can see the histograms. Very nice one. I'm running. Feature importance with the direction, so that's nice as well. So you give me the data set, I'm training it with 2 models, like GBM and Lasso, and showing you the 2 feature importance, so you can just have it out of the box very easily. And this is something nice, I have anomalies. So give me the data set and I can give you the anomalies right away. So it's a nice tool to validate your data set, any data set, whatever. All you need to do is just give me the train, the test, and it runs lots of these tests. And for each test, if it fails, there's a log file with all the detailed explanation. And by the way, right now it's all manual. People are working on that manually, but we want to add it to the auto training, so it will be automatic. And if there is a certain amount of failures, the model is not going to be trained and go to production. Guys, thank you very much. I'm out of time. And maybe 1 question or 2. I can take questions. All right, that's great. Questions, guys? Yes. So I actually added Lime and Shapley and all the LE5 features as well, so you will be able to run them as well. Yeah, that's true. It's not there. We don't have so many computer vision problems, but it's on the roadmap to add it. Yeah. For unstructured data, what kind of unstructured time series and stuff like that? No. Right now, it's not yet. But we're actually thinking about it. Another question? No. All right. Thank you, guys. Bye-bye.